Unit 4, to start us off, we'll look at 4.1, negative and zero exponents. So this will be our first section in our new unit on properties of exponents, and our goal is to be able to simplify expressions with negative exponents and with zero exponents. So when we start looking at exponents, we've been practicing ones where we would do 3 squared, something like this. So if we had 3 squared, maybe we can already do these in our head where we have 3 times 3, and we would know this equals 9. Okay, so what about 3 to the third? What does that look like? So if I took 3 squared, is 9. What about if I go up and say 3 to the third? Okay, now that is 3 times 3 times 3, which we did with our radicals, and we found 27. And we could even go here and say, okay, what about 3 to the fourth, which is now 3 times 3 times 3 times 3, all the way to 81. And so as we see here, we get our repeated multiplication where we have 3 times 3, 3 times 3 times 3, and then we go 3 times 3 times 3 times 3. Okay, so what about going the other direction? What about 3 to the first? Okay, so that takes away 1 3. So 3 to the first is just itself. Okay, so what about 3 to the 0? What would that be? So if I look, each time I'm taking one away, what operation undoes multiplication? So if I go this direction, I'm going to start dividing by 3. Divide by 3 takes away this one. Divide by 3 takes away this one. Divide by 3 takes away this one. Divide by 3, I'm going to get 1. So if I check that on my calculator, because man, all these are 3's, and now I have 1. Let's see what that looks like. 3, and I'm going to use our little caret here, to the 0. And that's 1. Okay, so that makes sense. So anytime I start with this, if I had said, okay, let's take this number and make it 30. 30, 30, 30, 30, 30, 30, 30, 30, 30. Whew, okay, so 30 to the 1 would be 30. 30 squared would be 900. 30 to the third would be 2700. Right? Let me check. 30 to the third. That's big. Oh, 3 zeros. Oh yeah, 1, 2, 3 zeros, 3 zeros. To the fourth, 1, 2, 3, 4 zeros. Okay, so now we have this here. So again, if I did 30 to the 0, okay, times 30 times 30 times 30, going backwards, divide by 30, divide by 30, divide by 30. 30 divided by 30, still 1. So if I check it on my calculator, again, 30 to the power of 0, still 1. So that's our rule for zero exponents. So right now, our first rule for our exponent properties is going to be anything, okay, anything that gets raised to the 0 power is 1. And that is a rule that works every single time. It doesn't matter if I took Mrs. Dale and I raised this to the 0 power, that's 1. Whatever I do, anything raised to the 0 is 1. So if I take negative 7,001, raise it to the 0, that's 1. I take an unknown value, raise it to the 0, that's 1. This one says take the opposite of 3 raised to the 0. So what is 3 raised to the 0? 1. What's the opposite of 1? Negative 1. This one says take negative 3 to the 0. That's 1. The negative makes a difference here. Inside the parentheses, anything to the 0 is 1. This is the part that's being raised to the 0 here, and it says take the opposite of whatever is being raised to the 0. In this one, we have a and then b to the 0. So a remains, but b to the 0 is 1. A times 1, a. Okay, so now we're adding some numbers in here. 4, I can bring that down. I have a squared. Don't know what that is. A to the 0, that's 1. B to the third, don't know what that is. 4 times 1, I can combine those. A squared, b to the third. So again, I know this is 1, so I can simplify that further. Similar to what we did on this one, this is something to the 0, so that's 1, and I want the opposite of that. There's -1 again. Something to the 0 is 1, and then it says to square that something. So 1 squared, +1. So this rule we can apply in many different ways, where it could be the entire thing or part of an expression that we can keep simplifying. So our first rule here for 0 exponents is anything raised to the 0 power is 1. All right, so our next idea is now our negative exponents. What happens when we have negative exponents? So if we took this and we started back at 3, because we've been working with 3, so we know this one a little bit more. So if we said, okay, we're going to start with 3 squared, that's 3 times 3, gives us 9. 3 to the third, 3 times 3 times 3, and we said was 27. 3 to the fourth, 3 times 3 times 3 times 3 was 81. And we said if we go down, we divide 1 3 out, and if we go to 0, divide a 3 out of 3, that goes back to 1. So what if I keep going and now have a negative exponent? Okay, so if I go this way, I should divide by. If I go this way, I should multiply by the 3 base here. So what about 3 to the 1, or 3 to the -2, or 3 to the -3? Does our pattern still hold up? That anything this way is times 3, and anything this way is divided by 3. So if that follows, I should take 1 and divide by 3. Okay, so 1 divided by 3, let's see if I get that on my calculator for a -1 exponent here. So 3 to the, now I'm going to have a -1 exponent, is 1 divided by 3. That works. Okay, so then if I do this, now I'm going to divide by 3 again. Okay, so let's think what that would look like. I'm going to take 1 divided by 3 and divide it again. So that means I have 2 3's that I'm dividing by. The same exponent that I had here, similar to the same exponent I have here, which is now 1 over 9. Okay, so I'm going to check on my calculator because this is new, so I'm checking. 1 divided by, now I'm going to say, 3 to the -2, and see if that's our 1/9. There it is. So there seems to be a pattern happening here that if I have a negative exponent, I can move it to the denominator as that division, where this negative means division, and I have a pattern of the 1, 3, 9, 27, 81. I have 1, 3, 9. I bet this is 27. And if we check to the -4th, we would get 1 over 81. So this rule, this pattern that comes, actually establishes our exponent rule, which says anything to a negative power, we can move to the division of the positive power. So the exponent rule says move and change the sign of the exponent. So 3 to the -4, we can move it and change the sign of the exponent and simplify if we wanted, the 1 over 81. Move, change the sign of the exponent, simplify if we want, 1 over 9. Okay, this negative doesn't apply to the 7. Or I'm sorry, it applies to everything here, but this -1 only applies to the 7. So I'm going to take the -1 and treat it like -1 times 7 to the -1. So this -1 I'm bringing down, and 7 to the 1 is where I'm moving it, changing the sign here, which gives me -1/7. Now I have the entire thing here that needs to be moved and change the sign of the exponent. Notice I didn't change the sign in here. And I could simplify if I wanted to. A negative times a negative times a negative would be a negative, and 4 times 4 is 16, times 4 is 64. Right now we're starting to just kind of move and change the sign and know what it applies to. Like this 3 in A don't get changed by this -2. It only applies to the b. So the b moves to division and it becomes a positive exponent. Same thing here. That -4 only applies to the x, not the 7. So I'm going to move the x, change the power, and then I still can bring the t squared down here. So the last two, now we have a sign that's negative in the bottom. The rule says move and change the sign. So if it's in the denominator, I'm going to move it to the numerator and change the sign and combine if I can, but I can't do anything here. Same thing here. This w is going to move to the top and change the sign to positive, but that n stays down underneath. So we have two new rules today. We have our zero exponents and our negative exponents that we're practicing tonight. So if you have questions, let me know if you run into something. If it's all numbers, you can check your answers on your calculator. If it has variables in it, we need to make sure that we've simplified and combined everything else that we can. Let me know if you have questions, and have a good day.